Today we're going to be doing linear inequalities. I think in the earlier video I said linear inequalities, but it was just inequalities. Sorry. So this time we're going to be talking about linear inequalities. So basically it's a linear function, y, let's do greater than mx plus b. I don't know why I wrote the b like that, but there we go. So basically what this is a line that says all the values of y are true as long as it is greater than whatever line this is. So let's say we have this line, and I'm going to do a dotted line because we are not including this line in the solution. And if y is greater, well, here's our y-axis, so anything greater going that way will be shaded. This is a terrible drawing. Why don't we flip over to Desmos real quick, and I'll show you there. Okay, I did not stick the landing on that one. Sorry. So here we have over at Desmos, I've created a couple lines. First one here is y is greater than x plus 5. So you can see that this line here, let me get my pointer. This line here is the correct line for x plus 5, but it is dotted, which means that it is not included in the solution. And then everything that is greater than y, or greater than that line, is shaded. These are all true statements of this solution. So if we were to take a point here, let's say -6 and 4, you plug in -6 for x, 4 for y, -6 plus 5 is -1, 4 is greater than -1, so this point is true. Well, what happens if we did it the other way? So when you have less than, the bottom half is going to be shaded below the line. Even if I were to come in here and make this a negative number, still look, the bottom half is going to, and I'm pointing at the screen like you can see me point, the bottom half here is going to be shaded because it is part of the true statement. If we have greater than or equal to, or less than or equal to, the line is going to be solid. That means the solution is included with the line. So the line is part of the answers. Okay, so I'm given this inequality. It's a linear inequality, and I know that because I have a 1x and 1y. And I want to put this in slope-intercept form, just because it's easier to graph that way. So what do I need to do first? Well, we're just going to solve it like any other equality that we have. So any kind of just normal function. We're going to have to first subtract 4x from both sides. Okay, I'm going to bring everything down. -3y is less than or equal to -4x plus 9. Okay, now I'm dealing with a negative number here. So what do I need to do? What's going to happen to my sign? I'm going to divide by -3 both sides, and I have to divide everything by -3. -3, there we go. And this goes down to 1, so it's just going to be y. I dealt with a negative number. I have to flip my sign. So now it's going to be greater than or equal to. That's going to be a positive 4/3 x. This is now a negative number, minus 9 divided by 3 is 3. I can't believe I had to think about that. So when we graph this, any value, I'm just going to do a little any value that is greater than this line, so let's say it looks something like this, well, sort of. Any greater value is going to be shaded up here.